Now let us discuss about equivalence of DFA and regular expression, that is conversion from DFA to regular expression. Here the input is DFA. We have to convert DFA into the regular expression. So this is the DFA. We know what is DFA. In each state must consume all the symbols present in the alphabet. Here the input alphabet contains two symbols. They are 0 and 1. So on Q1 we uses 0 and 1. On Q2 we uses 0 and 1. And on Q3 we uses 0 and 1. Here totally we have to follow three steps. The first step is we have to construct equation for each and every state based upon the incoming edges. If you take Q1, what are the incoming edges of Q1? One is one is on applying 0, and another one is this is the only incoming edge. If you take Q2, so one edge is on applying 1, another edge is on applying 1 on Q3. Okay, these are the incoming edges. So this is the first step. We have to construct equation for each and every state based on the incoming edges. And the second step is for the starting state equation, we have to add epsilon. And the third step is we have to solve the equation for the final state. Here the final state is Q1. So we have to solve Q1 equation. Q1 equation will becomes the final equation. That will becomes the regular expression. Here we have to use Arden's theorem for simplification of the regular expression. Let us see the problem. So Q1 is equal to, so what are the incoming edges? We have only one incoming edge, that is on applying 0. So on applying 0 we will get, we have one more incoming edge, that is 0 on Q3. So Q1 on 0 means we will get Q1. Next Q3 on 0 means, we will get Q1. So Q3 on 0. So for the initial state we have to add the epsilon. This is the initial state as well as the final state. For the initial state we have to add the epsilon. Next Q2 incoming edge. So this is the first edge and this is the second edge. And we have one more edge. This is the third edge. So what is the first one? Q1 on applying 1. Q1 on applying 1. Second one, Q2 on applying 1. Third one, Q3 on applying 1. So next let us solve Q3. So for Q3 we have only one incoming edge, that is Q2. So Q3 is equal to Q2 into 0. Now we have to solve the equation for the Q1. Why? Because Q1 is the final state. So it will becomes the solution. Okay. For the final state we have to solve the problem. We have to solve the equation. So that equation will becomes the regular expression. Okay. Final state equation will becomes the regular expression. Okay. Q1. So Q1 is the final state. So how to get Q1? Q1 0 plus Q3 0. So we have to obtain Q3 value. But what is Q3? Q3 is obtained from Q2. So first we have to solve Q2. So first consider Q2. Why? Because on substituting Q2 only, we will get the Q3 value. So what is Q2? Q2 is equal to Q1 1 plus Q2 1 plus Q3 1. So Q2 is equal to Q1 1 plus Q2 1 plus Q3 1. What is Q3 value? Q3 means Q2 0. So let us substitute that value. So Q1 1 plus Q2 1 plus what is Q3 value? Q2 into 0 into 1. So Q2 is equal to Q1 into 1 plus, here Q2 is the common term. So we can common Q2. So then we will get 1 plus 0 into 1. This is in the form of R is equal to Q plus RP. R is equal to Q plus RP. We know Arden's theorem. Here for simplification purpose we uses Arden's theorem, Arden's method. So what is Arden's method? If the regular expression is in the form of R is equal to Q plus RP, then it is simplified as R is equal to QP star. Okay. Here R means Q2. R means Q2. This is Q, this is P. So we can simplify as R is equal to QP star. Okay, R is equal to QP star. So what is R? Q2 is equal to QP star. What is Q? Q1 into 1 P star. What is P? 1 plus 0 into 1 whole star. So Q2 is equal to Q1 into 1. So this is Q value and this is P value. So we got Q2 value now. So now we can substitute Q2 value in Q3. Then we will get Q3 in terms of the Q1. So let us directly substitute in Q1. So what is Q1? Q1 is equal to Q1 0 plus Q3 0 plus epsilon. So Q1 is equal to Q1 0 plus what is Q3? Q3 means Q2 0. So Q3 means Q2 0. Here we have one more 0 plus epsilon. So Q1 is equal to Q1 0 plus what is Q2 value? Already we got Q2 value. Already we got Q2 value. So what is Q2 value? What is Q2 value? What is Q2 value? This is Q2 value. This is final Q2 value. So Q1 into 1 into 1 plus 0 1 whole star. Here we have two more zeros. 0 0 plus epsilon. Plus epsilon. Okay. So if you observe the equation, here Q1 is common term. So Q1 is equal to, Q1 is common term. So 0 plus 1 into 1 plus 0 1 whole star into 0 0 plus epsilon. This is in the form of R is equal to Q plus RP. R is equal to Q plus RP. So this can be written as R is equal to QP star. R is equal to QP star. R is equal to Q plus RP. So this can be written as R is equal to QP star. So what is R? Q1 is equal to QP star. What is Q? Epsilon into P star. P star means 0 plus 1 into 1 plus 0 1 whole star into 0 0 whole star. QP star. So 0 plus 1 into 1 plus 0 1 whole star into 0 0 whole star. Epsilon into R star is nothing but R star only. So we can eliminate this epsilon now. So this is the regular expression for this DFA. So in this way we can solve any problem very easily for converting DFA into regular expression. Likewise, we can convert a finite automata to regular expression also. Finite automata means it may be DFA or NFA. NFA means on each state there is no need to use all the symbols present in the alphabet. On Q1 we can, if you take Q1 here, on Q1 we use 0 and 1. On Q2 we use 0 and 1. On Q3 we use 0 and 1. NFA means we may not use some symbols. Okay.